Hello everybody. In this video we're going to take our fountain model and we're going to create a source for our water at the top of the fountain and a source for our water at the bottom of the fountain. So over to Houdini, let's make a start. So to do that, what I'm going to do is bring in some geometry to use as the fountain, and we've supplied some geometry with this tutorial. It would be called fountaingeo.bgeo. So hopefully you've copied that to the directory that you're going to save your HIP file to. I've already saved my HIP file or my scene file. So let's load in our geometry from disk and then we can use that as the basis of our fountain. So I'm just going to reformat this interface a little bit. I'm going to click on this little up triangle here, which will expand this window. And I'm going to tap P for parameter, which will bring up a floating parameter pane here on the right. So there's nothing there, obviously, because we don't have any nodes selected. So I'm going to hit Tab and type Geo to bring in a geometry node. And let's call this fountain. So I'm keeping it uppercase because I'm going to render this geometry later, so I want this visible. And I tend to use lowercase for things that are not going to be visible a bit later on. So I'm going to dive inside and hit Tab and type File to create file node. And I'm going to click on the little browser and go and find that fountain geo that we've included with this tutorial. So make sure you download that, put that somewhere that you know. If I hit accept, we can see that's what it is. It's a quite basic little fountain with a bowl up here. There's a little nozzle to shoot the water out from. We've got a little container at the bottom here to, which should be filled with water. And I'll see the little fountain dripping off down here. So as always, we should work to scale. If we middle click on the node, we can see that the size here says it's 2.1 units by 1.3 by 1.3. So this is Houdini's units is 1 unit, 1 meter. This is about 1.5 meters high, about 2 meters long. So it's a reasonable sort of worldy type scale. So that's good. We've got our fountain in. I'm going to create a null. And we'll just call this fountain out. So we can link to this a bit later on. So don't forget to save. And you can either click on the color palette here or tap C, and you can color the nodes. You can resize this, by the way, if you drag there. But what I want to do is just recolor this node red. I like my output nodes to be red. That means when I'm zoomed out, I can quickly see which nodes that are the ones at the end of the network or the important ones. If you tap C again, this will disappear for you. So I'm going to come up one, and I can see my fountain up here now. So what I want to do is create our FLIP sim, our fluid particle sim, using this geometry. And for that, I'm going to do that in another network. I like to work in separate networks doing certain things and then bring them together later. That means I can keep this as the sort of the node for rendering the fountain. I can have a node and bring the water out and render the water with that, etc., etc. So I'm going to create another container just for the sim. So let's hit Tab and type geometry. And let's call this water sim. You'll notice I've used lowercase because I'm not necessarily going to visualize this node later on. I'm going to export the contents out of here and visualize them elsewhere. But this node, I am going to visualize the fountain, so I keep it uppercase. So here's our water sim. Let's go inside, and you'll see we're ghosting the level above. If you do space Y, or you come up here and turn off the ghosting, hide other objects, then you won't see what's visible from the other networks. The reason I've done that is because I actually want to bring in that fountain to this network because I want to create the source for my simulation. So let's do that. Let's hit Tab and type object merge. So this will allow us to bring in geometry from other networks. We'll call this object merge fountain, just so we know what's going on. We can click on the little browser here. We can open up our fountain and find our null. The other reason we give them uppercase letters is because they appear at the top of these little browsers, which is handy when you've got a lot of nodes. So they're easy to find. So we'll click that. We also want to choose this into this object just in case you've transformed it at the upper level, which you shouldn't have done. But that's always a good safe thing to turn on anyway. And then we have our fountain brought into this network. You'll notice we've provided groups for this, so this is going to come in handy in a minute. So I'm just going to create another null very quickly just to help organize things. And I'm going to call this fountain in. Again, let's just give that a green colour. Why not? Green for in, red for out. So don't forget to save your scene at this point. So I want to create two sort of sources for my water. First of all, I want to create a source for the actual fountain bit. So we'll call this the fountain source. So this is where the water's sort of spewing up in the air in a kind of a noisy fashion, and it's going to come down, splash in the bowl here, and then run down. And then it's going to run into the pool here. Now, we don't want to have to run the sim so it runs down here and then fills this up over time. But it'd be a good idea to start with this already full. So we'll create a source of water for this part as well. So let's do that. Let's create the sources, and then we'll talk about how to simulate that efficiently. So the first thing I want to do is isolate the sort of main. Actually, let's do the water at the base here first. So what I'm going to do is I'm going to hit tab and type split. So split node's handy. It will allow us to split the object into two streams based on groups. And you'll see we already have some groups here. So I'm going to choose nozzle. And you'll see this is splitting out the nozzle, which is the little tube at the top here. If I template the input node, you can see where that is in relation to the model. Let's untemplate that. So this is where I want my sort of source to go. No, sorry, I'm not doing the nozzle. I said I was going to do the base first. Let's get rid of that group. Let's choose base. There we go. I'm going to do the base water first. So if we look at the base, you'll see by using the different group here, it splits off whichever. Out of the other output here comes the rest of the geometry. So this will be the bowl and everything else. We can just check that out actually just by popping a null in. So you'll see out of this side is what we asked for the group. Out of this side is everything else. And then we can merge them back together again later. Anyway, we digress. So what I want to do is I want to fill this up with some geometry that fits that gap perfectly. So the easiest thing we can do is use a Boolean in the intersect mode, or rather subtract mode, and then find out sort of this gap between two shapes. And to do that, I'm going to create an object like a bounding box around our fountain. So let's do that. Let's hit tab and type bound. So this will just create a bounding box around our geometry here. So you'll see the geometry there. We can template that. You'll see it just fits the bounding box because it's a square shape. It pretty much looks the same. So what I want to do is just shrink it ever so slightly. So I'm going to template my split here so I can see just the base. And on the bounds here, let's just shrink in the upper padding here. So the upper padding at the bottom is actually the top bits. So this is the positive X, Y, and Z. So if we look at our little gnomon down here, you can see, let's orientate it the correct way around, which is this way around. That's why Z is forwards and X is going off to the right. So when we say the upper padding, that's the positive end of the X, which will be here, or the positive Z, which will be this face, or the positive Y, which are this face, and the lower padding are the negative sides, which will be this side for the X, back for the Z, and the bottom for the Y. So I'm just going to shrink it by putting a bit of a negative, let's put -0.1, in on the upper paddings. So you see all the positive sides are shrunken a little bit. Let's also do that in the negative, in the lower padding of the X and the Z, but not the Y. I want this to stay on the bottom of the Y. If I actually keep the Y at 0, 0, you'll see we're filling in the whole shape, top and bottom, but the sides, they've been pulled in. If I actually just show you where we are, you'll see it's this shape that I want to fill. If I just template the bound, you'll see the bound is out inside of this edge, but outside of this edge. So we're trying to isolate this little box here to fill up. I could actually take the, where are we, in the gnomon there, that's the lower padding in the X. That's this one. I could bring that in further, something like that if we want to. And then I don't want it to fill all the way to top here. That's why in the upper padding, I'm just going to bring that into -0.1 as well. So if we have a look down now, in relation to that templated, you'll see this water is only going to be that deep. Because the deeper it is, the more particles you're going to have and the slower it's going to take to sim. So you want it not too deep. So if you have a look, you'll see that brighter line. See, it's just under halfway filled. And you can adjust that here with this upper padding. We can make less water or more water. So we'll keep it at 0.1. So what I'm going to do is I'm going to subtract the big shape from this shape. So if we do a Boolean subtract, we can take this shape here and that shape there. And then you'll see we get, oh, let me just template these properly. Oh, sorry, I don't want to split it. I want to do it from the split here because, yeah, remember this second output is everything else. We want to do it from the first output. There we go. So if you do a subtract, so we'll take this shape and we're going to subtract this shape from it. We're left with the gap in between, or what would become the fluid. So if I just template the main bottom of the fountain, you'll see there's a little slab or geometry to represent our water. And again, we can adjust this upper padding and make more or less water if we want. I'm going to keep that at 0.1. So let's make a null for the bottom of this so we know we're finished with this bit. We'll call this source water. This will be like the bottom tank of water. And again, I'll just make that a red so I know that's the end of sort of making this little bit of the network. Awesome. So the next bit I want to do is create the other source, which is the bit for the fountain here. So for that, let's use another split. Let's put that over here. And this time we will split off, let's just turn off the templating. Let's split off the nozzle. So we have this little nozzle here. So I'm not going to use the nozzle as a source actually. I'm going to create a sphere that sits on the top of the nozzle and that will become the source of my water. And the reason I'm doing that is because I can add some attributes to that to control the water. So what attributes can we add? Well, it's very simple. We can add a velocity attribute, a point velocity attribute. So we'll set that up now, and then when we look at running the sim, we'll see the effect of playing with that. And there's various other attributes that you can inherit from your source geometries too, things like viscosity and in fact any custom attribute you want to. But we're not really going to look into that, but we will use the velocity though. So let's create a sphere first of all, be my actual source. So let's create a sphere here. So let's tap F to frame it. So I want this to be a polygon sphere. We'll increase the frequency up quite high, something like 9. It's got a bunch of points to deform. And let's just, I don't know what size I want. What I want to do is I want to put it in position. Let's tap F of this cylinder. So there's an easy way we can position the sphere to the cylinder without eyeballing it. We can use a match size node. So a match size node has a couple of functions. If I just plug the sphere in first of all and tap F, you'll see it does nothing at the minute, but we can do various things. We could, for example, take the minimum bounding box or justify to the minimum Y bounding box. What that does, it just moves it to the bottom of the Y bounding box. You'll see now it sits on the grid. If we do it to the max, it'll be on the top of the sphere. So if we do it to the min, it now sits with the base on the origin there. So it just moves it to be on the bottom of the bounding box, which is pretty handy. But it's got another feature. We can actually use another geometry as reference. If I plug the nozzle into the right-hand side here, we can actually say on the match size, you can match to the bounding box here of the other object. So we want it to be on the top of the cylinder. So I'm going to say go to the max of the cylinder's bounding box. If I tap F to frame this and just template the cylinder, see there's the cylinder and our sphere is on the top of the bounding box. This is a little large, so let's try maybe 0.005. That's probably a little too small. So let's try 0.05, maybe 0.04, something like that. Let's tap F. There we go, that's on top of my cylinder. Yep, so that's nice and small. Maybe make that a bit bigger in a minute. So look, if we do to the minimum of the bounding box, you'll see we've got the minimum of our sphere's bounding box is matching the minimum of the tube's bounding box. Obviously, set this to max, it'll be on the bottom. we want the minimum bounding box of the sphere to be on the maximum, or the top bounding box in Y of the cylinder there. So that procedurally places it for us, which is really handy. I don't have to eyeball it in there. So the next thing I want to do actually is add a mounting SOP so we can create some interesting velocities or some motions onto this. Because if you think about it, a fountain of water is kind of irregular. I mean, the mountain SOP we can animate over time, and we can use the moving points to create some interesting velocities. What I want to do actually is just stretch my sphere here, a bit of a longer shape. There we go. It's a bit taller, and it'll just give more of an interesting emission, I think. So in the mountain SOP, first thing I want to do actually is animate this. So if we come down to animation, there we go. Oh, that's a bit strong, isn't it? Let's bring the amplitude down. Let's try an order of 10. Let's try something like 0.02. There we go. That's not too bad. We've got to reduce the element size because we're quite small here. The scene scale is quite small. Oh, there you go, 0.03. That looks nice and interesting. Oh yeah, what else are we going to do? The pulse duration. Let me put this to 0.2, so it's changing quite quickly. If I press play, it's going to go nuts. Let me turn this little clock on, so we're going in real time. There we go, that's kind of the speed we're talking about. That's interesting. That kind of looks kind of cool. Is that in real time? If I do tap D for the display options, we can go to guides. Oh, turn on the FPS here. That's 24 FPS. Yeah, that looks all right. I've got an interesting looking sphere animation there. Cool. So we want this to kind of create some interesting velocities for us. So what I'm going to do is hit tab and type point velocity. There we go. And here we can add various velocities, various things about the velocity. You'll notice it's computing the velocity from the deformation, but we can add some noise and we can add some direction to this, which we'll do a bit later on once we set up the sim. But here we've just got the ability to do that. We can preview the velocity by turning on here, display point trails. If we press play, interestingly, it's not displaying the V attribute, even though we have it there. The other thing we can do is click on information and just click on V, and then sometimes the visualizer should show up there as well. Interesting that it's not. Tap F. Oh, there we go. It's because it's the match size I was visualizing. Let's turn off V. Let's do that again. So if you display the match size, tap F so you can see it. You can turn on the point trails here and you'll see them as little green things. If I tap W for wireframe, we'll see those little lines. And like I said, you could also click on the information here and visualize these attributes. So if I click on the V here, we see it as point trails, a little bit longer. We can see they're doing interesting things. I mean, if we go to the point velocity here and we put a value in the Y, for example, let's put a value of 3. You'll see it shoots right up. Still got noise on it, but we're shooting the values right up. Put 2 or 1 in to make it more directional. But we'll mess around with this a bit later on once we set up the sim. So that's interesting. We've got our, let me turn this off. So to turn this off, you can click back on the I here and just click back on the V. Or instead of clicking on the V, if I just turn that back on, you can also see where here's the little lollipop icon. You can right click and you can see the V attribute there, which you can toggle it off here too. If you turn off the lollipop, then none of the visualizers will work. So there's 2 places you can turn that back on. So that's good. The last thing I want to do actually is just make a new group for this geometry here, because we've got this emitter. So we'll call this group the flip source. There we go, flip source. Excellent. So the last thing I want to do is just make a copy of this null, and we'll call this source fountain. So that'll be the source of our fountain. So we've got 2 sources here basically. Here's one called flip source, and if we have a look, this is moving along and with some velocities that we can play with. And this guy's called source water, and that's just our base of our water there. We could tidy this up and get rid of those groups. So we could use a group delete node just to keep things a bit tidy. And we can choose this delete unused groups. So you'll notice here these are empty groups. So this will just remove all of those for us nice and easily. And we're just left with this one group called base. Actually, let's remove that as well. Let's choose that base. We don't need this as a group later on. We might want that as a group possibly later on. Well, just for sake of completeness, actually, let's call this over here. Call this water source. In fact, let's be consistent with what we called them. So let's call this source water, and let's call this group here source fountain. There we go. So it's got one group here for the source fountain, there for the source water. So don't forget to save your scene. And then what we'll do is in the next video, we will set up the actual flip simulation based on this.